हेलो डियर स्टूडेंट्स। आज का जो हमारा टॉपिक है, वी आर गोइंग टू डिस्कस अबाउट द डिफरेंट concepts, the different examples in classical mechanics. So we can take different concepts like degrees of freedom, generalized coordinate, or the constraints in different systems, and we'll take some examples. So in each case, तो पहला जो हमारा टॉपिक यहाँ पे है, सो दैट इज बेसिकली द डिग्रीज ऑफ फ्रीडम। तो हम कैसे डिग्रीज ऑफ फ्रीडम डिफाइन करते हैं? सो एज यू माइट हैव ऑलरेडी discussed in your classes that it is the minimum number of independent coordinates, so that is needed to required to specify the motion of a particle or a system of particles. तो अगर हमें एक पार्टिकल फ्री स्पेस में होगा या मतलब किसी रीजन में होगा, तो इसके इंडिपेंडेंट मोशंस कितने पॉसिबल? इंडिपेंडेंट मीन्स इट इज इंडिपेंडेंट on the different these possible motions, right? So that means, so this is how you can define the degrees of freedom, right? तो यहाँ पे और एक concept है, that's basically the generalized coordinate. तो generalized coordinate is again it is relevant to that, so there are degrees of freedom, but in most cases we are saying that generalized coordinate is equal to that is equal to that degree of freedom. So that's what I wrote here, that in maximum cases degrees of freedom will be equal to the generalized coordinate. Now अगर हम generalized coordinate निकालेंगे, so that means we can define the generalized coordinate as that's equal to 3n minus beta, right? So that's 3n minus beta. So alpha is our generalized coordinate, right? So we can say that it's equal to 3n minus beta, right? And this capital N indicates that the number of particles, and this beta is that is the constrained one, right? So constraint, we know that, which basically a kind of which basically seizes the motion of the particle, right? Suppose a particle is moving in some free space. If I put something, so it basically restricts its motion. So instead of अगर particle free space में move होगा, तो it can then particle can move in along one direction or it can move in two directions. So that means एक degree of freedom एक motion इसने इसकी seize की है. So that is simply a constraint. तो हम constraint कैसे define कर सकते हैं? Now, so this beta is the constraint. So that means we have different kinds of constraints in classical mechanics, where we can have time dependent or time independent constraint. We can have those celeronomic or rehonomic. So we can have different kinds of constraints, and we will take those constraints. We will take some examples, and so that we can see the effect of that constraint and see what should be the degree of freedom in those system of particles or a single particle. Okay. So that means यहाँ पे मैं लिख सकता हूँ that the generalized coordinate is equal to 3n minus beta. This n represents the number of particles and beta is the constraint involved. Now second is that, so that means degrees of freedom मैं लिख सकता हूँ that usually in our books we wrote that degree of freedom is represented by small f, and that's equal to 3n minus beta. So this n represents the number of particles and beta is constraint. Now instead of that, so that means this 3 क्या है यहाँ पे? 3 basically क्या है? So that is purely that if we consider a particle in 3 dimension, तो वहाँ पे possible जो motions particle के होंगे that can be along x, along y or along z direction. Okay. Now if I generalize this equation, अगर मैं इसको generalize करूँगा, I can write it for the d dimension, right? So that means I can write the degrees of freedom will be equal to, that is dn minus beta. So that means this d indicates the dimensions, क्योंकि particle move हो सकता है free space में, it can move in a plane or it can move along some specific path in one direction, you can see, right? So that means I can write for so that means if we consider some particle or a body in free space, the d will be equal to 3 in that case. Or if we consider the motion of that particle in some plane, d will be equal to, or along a path, d will be equal to 1. So accordingly, we can say that the degree of freedom will be equal to dn minus beta. Now, अगर मैं एक simple example लूँगा, अगर मैं if I consider a particle in some free space or a body in some free space, right? So in that case, we can say that if we have some mass m that is in free space, because I'm representing its coordinates or x, y, z, so that means it can have all possible motions. It can go along x or y or z direction. So in that case, what should be the degree of freedom? Because तो यहाँ पे मैंने ऑलरेडी कहा कि जो पार्टिकल यहाँ पे है, पार्टिकल इज इन फ्री स्पेस, so that means d will be equal to 3, and number of particles, it's a single particle. Okay. or a single body, and beta equal to 0 because there is no constraint involved. तो मैं आपको already so in our this in our this class, so I'm going to discuss some of the examples. कुछ examples मैं यहाँ पे बताऊंगा जहाँ पे constraint present होगा. So that means here f will be equal to, that will be equal to dn because d equal to 3 and n is equal to 1 and there is no constraint, so beta यहाँ पे 0 होगा. So that means this f will be equal to 3. So that means अगर particle free space में होगा तो that means all कितने possible motion है, it will be 3. So that means degrees of freedom will be 3. Okay. So this is first case. अगर मैं second case लूँगा, suppose अगर हमारे पास एक particle होगा और a ball which is moving along some specific path. Okay. So that means यहाँ पे जो trajectory, this is the trajectory of a ball. This is the trajectory of a ball. Trajectory of a ball. This is the particular trajectory. तो जिस trajectory पे ये ball move हो रहा है, या ये एक path है जिस path पे ये ball move हो रही है, right? But it is in xy plane. So that means first of all, क्योंकि जो हमारी relation है that is f equal to dn minus beta. तो पहले मैंने ऑलरेडी कहा कि जो बॉल मूव हो रहे हैं ये मूव हो रहे हैं इन सम xy plane और y z plane. तो इट इज रिटन हियर xy plane. तो दैट मींस यहाँ पे मैं कह सकता हूँ जो d होगा यहाँ पे d will be equal to 2 because it is in 2 dimension. Motion is in 2 dimension. Okay. Now number of particles n will be equal to 1 and what should be the constraint? Constraint will be equal to 1 here. Because why I am saying constraint? Because this ball basically seizes it is one motion of that ball. तो ये इसकी एक motion खत्म करता है, right? So that means तो यहाँ पे constraint present है. That constraint will be equal to, so we have one constraint present here, so beta will be 1 here. So that means we can write the degree of freedom will be equal to nd minus beta, that is 2 into 1 minus 1 because यहाँ पे constraint present है. So that means degree of freedom will be equal to 1 because 2 into 1 minus 1, that is f equal to 1. तो यहाँ पे, so that means यहाँ पे एक possible motion है. So that can be along x or it can be along y. Now instead of that we have one more example जहाँ पे degree of freedom again 1 के बराबर आएगा. So that means अगर मेरे पास motion of a body है और a motion of a ball है, that is governed by this equation. We have y equal to some sine of x, or we can have some cosine of x, tangent of x. So because we know the graph, we know that the graph of this sine of x, it is like this, right? तो ball यहाँ से move हो रहा है ऐसे, right? So in that case, again this track basically says it is one motion. So that means we have one constraint present here, right? So in that case, again these degrees of freedom will be equal to 1. Okay. And if I take one more example, suppose हमारे पास एक motion of a ball है along a circular path. तो अगर circular path में होगा यहाँ पे, but that path is fixed. So that means जो radius यहाँ पे circle का होगा, that is fixed here. So that means this r can act as a constraint, a kind of constraint here, right? So that means this path is it is following this particular path. It's not deviating. So that means this r will act as a kind of constraint here. So that means there will be constraint present in this possible motion. If we consider a motion of a ball in a plane, but having some particular path, it fixed radius you can see. अगर यहाँ पे radius fixed होगा. So in that case, जो degree of freedom होगा, that will be again because constraint यहाँ पे present है. जब constraint present होगा, तो that means beta will be equal to 1. So degree of freedom will be equal to, that's again equal to 1. So that means in all the cases, मैंने 3 cases लिए हैं. तो first case मैंने क्या लिया है? So if I revise these things, so first case मैंने क्या लिया है? So it is okay because there was no constraint. But this case was, अगर मैं ball एक लूँगा which is following some particular path or a trajectory. Second, if I define path of a ball along this track which is followed by this equation, or you can say that path of a ball along a circular path in a plane but with fixed radius. So that means in all the 3 cases हमारा जो degree of freedom 1 के बराबर आता है. So what does that mean? So that means अगर हमारे पास कोई प्रॉब्लम होगी, कोई एग्जांपल होगी जहाँ पे लिखा होगा along a something, along a particular path, along a circular radius. So in all those cases, जो हमारा degree of freedom होता है, that's equal to 1, right? So this was so far these three examples are concerned. Now if I take another case, if I take this case, if I take this case, यहाँ पे motion of a bead along in xy plane along this path, right? तो यहाँ पे मैं कह सकता हूँ theta is fixed here. When theta is fixed, so that means this path is fixed, right? So again here f will be equal to, that is equal to 1 into 2 minus 1, because जो d यहाँ पे होगा dimension that is equal to 2, because it is moving in a plane. तो जैसे यहाँ पे circular path होगा, motion of a body along a circular path in xy plane, यहाँ पे भी dimension 2 था, यहाँ पे भी dimension 2 है, but there is again a constraint 1, that's small, and that's equal to 1. So in all the four cases जो यहाँ पे degree of freedom 1 के बराबर, right? Now let's take some more examples. Now again if I take the previous case, तो वहाँ पे मैंने कहा कि अगर हमारे पास एक ball होगी and the motion of that ball is circular with fixed radius r. But here now I am saying that अगर यहाँ पे boy is again or a ball is moving in a circular path, अगर एक athlete लेंगे तो वो एक सर्कुलर ग्राउंड में चक्कर लगाता है, राइट? तो हम ऐसे कह सकते हैं कि तो दैट मीन्स जो पाथ इस एथलीट और बॉय की होगी, सो दैट इज सर्कुलर, बट इट इज नॉट मेंशन्ड, इट इज फॉलोइंग सम पर्टिकुलर सर्कुलर ट्रैक, तो इट इज नॉट मेंशन्ड. तो दैट सर्कुलर ट्रैक विल बी दिस वन, वो ये भी हो सकता है, वो ये भी हो सकता है, कोई भी पॉसिबल सर्कुलर ट्रैक हो सकता है. So that means this r is not fixed, right? Although it is moving in plane, but that r is not fixed. That r can be this one, it can be this one, it can be this one, or it can be this one. So that means this r is not fixed here. So in such a case, there should be no degrees of freedom. So this is the basic difference. Because here I am saying that it is moving along a circular track, but that circular track, that circular path is not fixed. That वो circular path कोई भी हो सकता है, या वो small circle भी बना सकता है, ये वाला भी बना सकता है, right? In that case, beta will be equal to 0. तो जब बीटा 0 होगा तो degree of freedom will be equal to 2, right? Or you can take one more example. Suppose I will take these two examples. So I am basically making three cones here. Okay, so let us take these two cases. तो केस फर्स्ट जो है, तो केस फर्स्ट है, तो केस फर्स्ट में ओके लेट अस टेक केस थर्ड फर्स्ट. केस थर्ड पहले मैं केस थर्ड लूंगा. तो केस थर्ड में हम कह रहे हैं कि एक बॉल जो है यहाँ पे, दिस इज अ बॉल, वो मूव हो रही है along the surface of that cone. तो जब अभी कून लेंगे तो उसके सरफेस पे एक बॉल मूव हो रही है. जब एक सरफेस पे बॉल मूव हो रही है, इन दैट केस जो रेडियस उस कून का होगा वो तो फिक्स होगा, राइट? तो वो तो चेंज नहीं होगा. सो दैट मीन्स दिस देयर विल बी कंस्ट्रेंट प्रेजेंट, बिकॉज ये इसके सरफेस पे मूव हो रही है, तो ये ऐसे मूव हो रही है. तो दैट मीन्स दिस आर इज फिक्स्ड. अगर मैं यहाँ पे भी लूंगा, यहाँ पे, तो किसी भी पॉइंट पे मैं लूंगा तो आर वो फिक्स्ड होगा. तो दैट मीन्स जो यहाँ पे बीटा का वैल्यू वो 1 के बराबर होगा. तो दैट मीन्स इन दिस केस बीटा 1 के बराबर होगा. एंड डी आपको पता है बिकॉज इट इज मूविंग इन 2 डायमेंशन. So d will be equal to 2 and this n will be equal to 1. So that means f will be equal to, that's equal to 2 into 1 minus 1. Right? Now, so this was a simple case we have already kiya, so that means it is on this, on that circular, right? Now, अगर मैं ये दो केसेस लूंगा अभी, तो यहाँ पे मैं कह रहा हूँ कि जब अब बॉल जो है यहाँ पे, दिस इज द बॉल, तो ये जो बॉल है, it is moving on the inner surface or the outer surface of that. अब मैं यहाँ पे बॉल मूव नहीं करा रहा हूँ ऑन द सरफेस ऑफ दैट ऑन द अपर सरफेस या एट दिस पोजीशन, तो यहाँ पे मैं मूव नहीं कर रहा, अब मैं इसके सरफेस यहाँ पे मूव करा रहा हूँ, राइट? So that means I am saying that the ball is moving on the surface of the cone, or on the outer surface of the cone, or on the inner surface of the cone. So when it is on, so that means यहाँ पे ये पॉसिबल मोशन ऐसे भी हो सकता है, ये यहाँ पे भी मूव करेगा, बिकॉज ये तो पूरा सरफेस है। अगर हम आउटर सरफेस की बात करेंगे तो इसकी पॉसिबल मोशन यहाँ पे भी हो सकती है, यहाँ पे भी मूव कर सकता है, यहाँ पे भी मूव कर सकता है, यहाँ पे भी, यहाँ पे भी। या अगर मैं इनर सरफेस की बात करूंगा तो ये यहाँ पे भी मूव कर सकता है, यहाँ पे भी मूव कर सकता है ऑन द इनर सरफेस। सो दैट मीन्स जो इसका रेडियस होगा एट द डिफरेंट रीजन्स ऑफ दैट इनर और आउटर सरफेस वो कांस्टेंट नहीं रहेगा। सो दैट मीन्स देयर इज नो कांस्टेंट इन्वॉल्व इन दीज टू केसेस व्हेन द बॉल इज मूविंग on the inner surface or on the outer surface of the ball. So that means in these two cases जो डिग्री ऑफ फ्रीडम यहाँ पे होगा, सॉरी जो बीटा होगा, कांस्टेंट जो होगा यहाँ पे कांस्टेंट 0 के बराबर होगा। तो दैट मीन्स इन दिस केसेस बीटा इक्वल टू 0, n इक्वल टू 1 and d इक्वल टू 2। सो दैट मीन्स f will be equal to, तो डिग्री ऑफ फ्रीडम किसके बराबर आएगा? दैट विल बी इक्वल टू 2। इज इट ओके? सो व्हाट वी हैव कंक्लूडेड, तो हमने बेसिकली क्या सीखा? तो अगर हमारे पास कोई एग्जांपल दी होगी तो अगर वहां पे लिखा होगा इफ इट इज रिटन अलोंग ए पाथ, अलोंग ए सर्कुलर ट्रैक, along a path that is governed by some equation y equal to some a sin of omega t plus something, right? In those cases, the degree of freedom will be equal to 1. So that means the constraint will be involved in those cases. जैसे यहाँ पे जो ball है, it is moving on the surface, on the top of the surface of the cone, at the periphery of the cone. Now, here, sorry, it is along, sorry. So this is along the surface of the top surface of the cone. But here, I am saying the ball is moving on the inner surface or on the outer surface of it. When it is written on of something, so in that cases, the degree of freedom, sorry, beta will be 0 there. Because beta is 0 here, there is no constraint involved. और अगर हम प्रीवियस एग्जांपल देखेंगे इस वाले केस में, तो यहाँ पे हम कह रहे हैं कि motion of a path on a circle, motion of a ball on a circular path. It is not along. So when it is written on a circular path, that circular path is not fixed. So that means when it is written on something, so in that cases there will be no constraint involved. So when there is no constraint involved, beta will, this f will be equal to 2. So degree of freedom वहाँ पे 2y. Right? So these were the two cases. तो जहाँ पे हम बता सकते हैं कि एक में constraint possible होगा when it is written along, और if it is written on of something, तो वहाँ पे degree of this beta will be 0. तो एक में degree of freedom 1 के बराबर आएगा when it is written along, and then degree of freedom will be equal to 2 if it is written on of something. Okay. So this is how you can distinguish these two cases. तो दैट मीन्स नाउ अगर हमारे पास, तो हमने एक सिंगल बॉडी की बात की, एक सिंगल पार्टिकल, अगर हमारे पास सिस्टम ऑफ पार्टिकल्स, तो दैट मीन्स इफ वी हैव अ सिस्टम ऑफ पार्टिकल्स, तो दैट मीन्स अगर हम सपोज टू बॉडी लाइक डायटोमिक या पॉलीएटॉमिक सिस्टम की बात करें, लाइक केमिस्ट्री में पढ़ा होगा आपने, लाइक ऑक्सीजन मॉलिक्यूल O2 और यू कैन हैव सम कार्बन डाइऑक्साइड CO2, right? So that means we can have diatomic or we can have polyatomic, right? So in those cases, we can see what should be the possible degrees of freedom. Okay. Now we can keep those things aside, but we will discuss in general some system of particles, right? So that means if we have तो अगर हमारे पास सिस्टम ऑफ पार्टिकल्स हो, राइट, तो दैट मीन्स वी कैन हैव मोर देन वन सिस्टम ऑफ पार्टिकल मीन्स, अभी तो सिंगल पार्टिकल की बात कर रहे हैं, तो अब हमारे पास मोर देन वन पार्टिकल है, तो दैट मीन्स वी कैन हैव more than 2, or you can write that we can have more than 2, or you can say that more than 1, so that means it's a system of particles, right? Or you can write more than 1, more than 1, okay? तो वहां पे हम डिग्री ऑफ सिस्टम, डिग्रीज ऑफ फ्रीडम कैसे लिख सकते हैं? नाउ देयर आर टू केसेस। तो पहला केस हम लेंगे, अगर हमारे पास सिस्टम ऑफ पार्टिकल्स होगा, अगर हमारे पास सिस्टम ऑफ पार्टिकल्स होगा तो विच आर नॉट इंटरेक्टिंग विद ईच अदर। तो टू केसेस है। पहला केस अगर हम देखेंगे, अगर इफ देयर इज नो इंटरेक्शन बिटवीन द सिस्टम ऑफ पार्टिकल्स, एंड सेकंड केस इफ देयर इज इंटरेक्शन। दो केस, अगर हमारे पास टू पार्टिकल्स हैं फ्री स्पेस में, अगर इसमें कुछ कनेक्शन नहीं किया है, इफ देयर इज नो इंटरेक्शन, तो वहाँ पे भी हम डिग्रीज ऑफ फ्रीडम निकाल सकते हैं, इट इज़ वेरी इजी। बट अगर हमारे पास सिस्टम ऑफ पार्टिकल्स या टू पार्टिकल सिस्टम होगा एंड दीज आर इंटर रिलेटेड विद ईच अदर, so in that case there will be constraint, so we can see what should be the degree of freedom. So these two cases are possible. Let us write the first case. तो फर्स्ट केस हमारा है केस फर्स्ट। तो इन केस फर्स्ट मैं कह रहा हूं पहला केस में ले रहा हूं दैट देयर इज नो इंटरेक्शन among the particles. You can say that there is no connection between the system of particles with each other. So this first case. So that means इनके लिए जो मेरा डिग्रीज ऑफ फ्रीडम होगा, so degrees of freedom that are represented by F, so that will be equal to ओके। सो दिस इज वेरी क्लियर। तो ये आपको पता है कि मैं कह रहा हूँ कि जो पार्टिकल्स है तो वहाँ पे कोई इंटरेक्शन नहीं है। लाइक अगर हम ऑक्सीजन मॉलिक्यूल की बात करेंगे O2, तो देयर इज सम बॉन्ड बिटवीन टू ऑक्सीजन मॉलिक्यूल्स, so these are there is interaction between them, so that means, but here I am saying that there is no interaction between the particles. So when there is no interaction, so that means degrees of freedom will be simply equal to the sum of degrees of freedom of individual particles. अगर हमारे पास टू पार्टिकल्स है, अगर दो पार्टिकल्स है, तो डिग्रीज ऑफ फ्रीडम विल बी, तो पहले की हम डिग्री ऑफ फ्रीडम निकालेंगे, उसके बाद सेकंड पार्टिकल की डिग्री ऑफ फ्रीडम निकालेंगे, देन कैलकुलेट देयर सम। और अगर हमारे पास n नंबर ऑफ पार्टिकल्स होंगे तो दैट मीन्स हमें इंडिविजुअली डिग्री ऑफ फ्रीडम पार्टिकल्स की देखनी है, देन कैलकुलेट द टोटल सम, दैट विल बी टोटल डिग्री ऑफ फ्रीडम। I am not writing here what should be that beta here. Why? Because so beta will be here, because अगर मैं F1 लिखूंगा तो F1 बेसिकली क्या है, so that is equal to N1 D1 minus beta. For this it will be right. So you can write it in that way if you are interested, right? So that means हम individually हम देखते हैं degree of freedom क्या होगा, right? So this first case. Let me give you a simple example. अगर हमारे पास अब टू डायटोमिक सिस्टम होगा, राइट? तो अगर हमारे पास टू पार्टिकल्स होंगे बट इन अ फ्री स्पेस, और यू कैन से इन अ प्लेन। सो एग्जांपल नंबर 1, यू कैन से दैट ओके। सो दैट मीन्स हमारे पास टू पार्टिकल्स हैं in free space. So I am not mentioning that it is in free. Okay, I have mentioned that two particles in free space. So we have two particles in free space. तो हमें देखना है कि what should be the total degree of freedom. Because this is the first case. Because I am saying that there is no interaction between the particles. तो जब interaction नहीं होगी तो there is no constraint. So this is so obvious, right? So that means how we can write the total degree of freedom. So total degree of freedom will be equal to, so that will be equal to degree of freedom due to mass m plus degree of freedom due to mass m. Right? So degree of freedom इसके लिए मुझे देखना है, because I can say that so it is moving in free space having coordinates x y z. So इसके भी coordinates x y z है, right? So we can say that जो total degree of freedom होगा वो degree of freedom due to this mass होगा due to this particle and due to this particle. Okay, so we can say that total degree of freedom will be equal to, so that will be equal to, because if I calculate the degree of freedom for this one, so this will be equal to n1 b1 minus beta1 plus beta2. So number of degrees of freedom will be 6. Okay, let me give you one more example. Okay, suppose we have so we are saying now the two balls moving on the surface of the sphere. Or I can take one more example. Okay, let us take this example. Okay, तो अगर हमारे पास we have two balls, because it is written here it's a sphere, it's not a circle, right? So when it is a sphere, so that means so it has so this degrees of freedom should be equal to 3 as per our con. But let us check if there is some constraint present or not, because this sphere has some radius r. Okay, I'm saying that it has some radius r. Okay, so in this case, तो यहाँ पे जो टू सिस्टम्स होंगे, तो मुझे जो मेरा टोटल डिग्री ऑफ फ्रीडम है इन दिस केस, तो वी आर सेइंग दैट द टोटल डिग्री ऑफ फ्रीडम विल बी इक्वल टू okay, so that means beta 1 represents the constraint that is involved in body of mass m1 and beta 2 is the constraint for this mass m2. तो यहाँ पे कंस्ट्रेंट होगा, बिकॉज दिस वेरी क्लियर, बिकॉज यहाँ पे ये इसको सीज करता है, although sphere means it's in 3 dimension. Okay, so that means ये मान जो मूव होगा it may be move in the 3 dimension, so along x y z it has all the 3 possible motions. So that means अगर मैं यहाँ पे कैलकुलेट करूँगा तो number of particles 1 है, d will be equal to 3 and beta will be equal to 1, because what that constraint is, it is because of the radius. So radius basically seizes its motion, it basically restricted its motion. ये इसको restrict करता है, किसको, mass m1 को इसको restrict करता है, that you need to move along some specific direction, along that region, along on the surface of that sphere. So that means it restricted its motion. So that means the constraint involved for this mass m1 will be equal to 1 and plus it will be equal to 1 into 3 minus 1. So it will be equal to, so that means degrees of freedom will be equal to 4. So these are, ये कौन से एग्जांपल्स है जब हमारे पास सिस्टम होगा दैट इज नॉट इंटरेक्टिंग. तो यहाँ पे कोई इंटरेक्शन नहीं है, बिकॉज ये इंडिपेंडेंटली मूव हो रहा है, कौन सा, मास m1 and mass m2 is moving independent. Okay, okay, so okay, let's take one more example. तो अब हम थोड़ा इसको ट्रिकी बनाएंगे, थोड़ा यही एग्जांपल मैं लूंगा, यही एग्जांपल लूंगा, इसको मैं कनेक्ट करूंगा, तो उसके बाद मैं देखूंगा तो इसकी डिग्री ऑफ फ्रीडम कितनी होगी, राइट? So let's take one more case. तो अगर हमारे पास again I will take a sphere, so this is sphere and we have two masses m1 and m2. These are connected by spring and this is radius r. Okay. So that means in this example, where basically two masses. Okay. So now I basically make some changes in our previous example. So previous example में वहाँ पे there was no connection between the two masses. ये mass freely move हो सकता है, but that radius basically restricted its motion. And similarly, mass m2 move हो सकता है on the surface of that sphere, but that radius also restricted motion. We have calculated. हमने देखा कि degree of freedom क्या होगा. Now in this case, तो इस केस में अब क्या मैं कह रहा हूँ कि हमारे पास two masses है. These are connected by some ideal spring and with spring constant k, and we can say that where the oscillations that are produced in the spring that are very small. So that means the oscillations produced. We can write okay the oscillations तो जो ऑसिलेशन प्रोड्यूस होगी स्प्रिंग में वो बहुत कम होगी. तो दैट मीन व्हाट डज दैट इंडिकेट. तो वो हमें क्या कह रहा है. तो वो कह रहा है कि अगर हमारे पास दो मास से इनको मैंने कनेक्ट किया स्प्रिंग से एज पर दिस फिगर शोज. तो ये दो मास मैंने कनेक्ट किए स्प्रिंग से. अगर ये मूव होगा, अगर ये रोटेट होगा द सरफेस ऑफ द स्फीयर, तो स्प्रिंग में थोड़ी वाइब्रेशन होगी. राइट. आई एम सेइंग आइडियल स्प्रिंग विद स्प्रिंग कांस्टेंट के, but the oscillation जो प्रोड्यूस होगी due to the motion of the mass m1, so those oscillations will be small because I have written that the oscillation produced in the spring is very small. So that means अगर इसको मैं perturb करूंगा, इसको मैं थोड़ा मूव कराऊंगा, तो इसमें oscillation प्रोड्यूस होगी, but those oscillations are very small because it is explicitly written in the question. तो क्वेश्चन में लिखा है. If it is not written in the question, then the case will be different. But here it is written that the oscillations produced in the spring is very small. So that means अगर एक मास को मैं थोड़ा चेंज करूंगा तो इससे spring में oscillation produce होगी, but that oscillation I am saying that I am assuming that those oscillations are very small. तो that means जो दूसरा मास होगा यहाँ पे m2, तो यहाँ पे जो दूसरा मास होगा तो ये वाला मास, तो जब oscillation प्रोड्यूस होगी तो those oscillations बहुत that will be very small, those will be very small, and that will not affect mass m2. तो वो m2 को affect नहीं करेगा. So that means तो ये दो cases है. So we can say that this is again we have two particles moving on the surface of the sphere and there is no interaction. These are not connected with each other. Okay. So that means in this case also, so this F will be equal to, so it will be equal to 2 plus 2. That is why 2 plus 2? Because F1 यहाँ पे because F1 क्या आएगा, तो F1 तो ये हमारा F2 है. तो because इसके लिए हमारा constraint 1 होगा, तो that constraint will be due to the radius of that sphere. And similarly for this okay sorry, so this F2, so this is degree of freedom for mass M2, तो इसके लिए भी degree of freedom 2 होगा. So it will be 2 plus 2 equal to 4. Now I can make a little bit modification. Instead of putting that spring, I can, if I put some string, अगर इसको मैं replace करूंगा string से, so what should be in our case? So that means if I consider again sphere, so having two masses, so this is mass m1, so I connecting these two, तो इनको मैं connect कर रहा हूँ, दो mass को connect कर रहा हूँ with that inextensible string. So in that case, So what should be the degree of freedom? तो डिग्री ऑफ फ्रीडम क्या हो सकता है यहाँ पे? So what should be the degree of freedom? So degree of freedom will be equal to, so that will be equal to, or you can take that. Okay, let me, so before that, so let me do one thing. Okay, I can take this example in second case because now I'm saying that there is interaction. So in a second, तो फर्स्ट केस में हमने कहा कि when there is no interaction between the particles, तो उसमें हमने देखा कि डिग्री ऑफ फ्रीडम कैसे निकालते हैं. अगर हमारे पास अब सिस्टम होगा why there is interaction between the particles are interconnected with each other, right? So in that case जो डिग्री ऑफ फ्रीडम हमारा सिस्टम का होगा, so this is SY stands for the system, degree of freedom for the system of particles, so that will be equal to F1 plus. So this beta represents the total constraint. Okay, तो जो total constraint इस सिस्टम में होगा तो उसको सब्ट्रैक्ट करना है. So let us take this example जो मैंने आगे बताया था आपको. So we have some sphere here. अगर हम एक स्फीयर लेंगे, इससे दो मास हम लेंगे m1 and that m2. So these are connected by a string. Okay, तो ये दो masses move हो रहे हैं on the surface of the sphere. तो surface of the sphere पे ये move हो रही है, and in addition to that, these masses are connected by inextensible string. So that means अगर ये mass move होगा, so it will affect the motion of this one, right? Or if this mass moves, if it travels some distance, so it will affect the mass m1 because these are connected through some inextensible string. So in that case, so what should be our degree of freedom in this case? So f जो होगा, so that will be equal to f1 plus f2 minus beta. So what should be f1? So f1 क्या होगा? So if I calculate f1 for this, so that will be equal to n1 d1 beta 1. So that will be equal to, because n1 हमारा it is 1 into 3 minus 1 plus 1 into 3. तो ये फर्स्ट केस, बिकॉज n1 यहाँ पे n1 1 के बराबर है, तो डायमेंशन बिकॉज इट्स मूविंग ऑन द सब स्फीयर, so d will dimension will be 3 here, and one constraint will be due to the radius because that radius restricted his motion on the surface of the sphere. Okay, so that means the constraint involved here will be 1 here, so it will be 1 plus 3 minus 1, and similarly दूसरे part will be. Now in addition to that, these are connected by the string, so that means there is one more constraint involved, right? So that will be equal to, that will be equal to 1. So that means I can write here, so this will be equal to, डिग्रीज ऑफ फ्रीडम यहाँ पे 3 के बराबर है, बिकॉज तो ये कंस्ट्रेंट किसकी वजह से है, ड्यू टू दिस इनएक्सटेंसिबल स्फीयर, and this constraint comes due to the radius of that sphere. Okay, now if you take now, in addition to that, अगर हमारे पास अब 3 पार्टिकल्स होंगे, 3 स्पेस, अगर हमारे पास पार्टिकल होंगे 3 पार्टिकल्स इन 3 स्पेस, we have 3 particles, this is m1, this is m2, and these are interconnected with each other with some strings having length L1, L2, L3. Right? So we can write the degree of freedom in this case will be equal to that is F1. So that will be equal to, तो किसके बराबर आएगा यहाँ पे? So this will be equal to, तो यहाँ पे आ सकता है that is 3 plus 3 minus, so what is constant here involved? So the constant should be 3. Okay, because so one constant is this due to length L1, one is due to L2 and one is due to L3. Because so that means the constant will be because F1 जो है यहाँ पे F1 अगर इंडिविजुअली लिखेंगे तो 3 पार्टिकल है उसके डिग्रीज ऑफ फ्रीडम 3 होंगे because there is no constant involved for mass M1. Similarly for M2 degree of freedom will be 3 because it is beta will be 0 individually. अगर separately देखेंगे this F1, F2 and F3, so that will be 3 plus 3 plus 3. Now there are three constants involved. One is due to the string L1, another is due to L2, and another is due to L3. So that will be 3 plus 3 minus 3. So it will be equal to 6. So F will be equal to 6. So there are 6 degrees of freedom or 6 possible motion for this triatomic molecule. Right? So in addition to that, you might have heard about that if we consider some simple pendulum. तो अगर हमारे पास एक simple pendulum होगा, so if I consider some, if we have a simple pendulum attached by a string mass m1 and it exhibits this oscillation. तो ये oscillation having length m. तो इसमें हमें देखना है कि what should be the degree of freedom. तो अगर हम degree of freedom यहाँ पे देखेंगे, so that will be equal to nd minus beta. So number of particles is 1 and d will be equal to 2 here. Okay. So because I'm saying that this pendulum is connected by, so this is inextensible. Inextensible setting. So that means in that case d will be equal to 2, l equal to 1 and beta will be equal to 1 because there is one constant in all that is due to the length, right? And this will be equal to 1. So f will be equal to 1. Now instead of that, अगर हम दूसरा case अब लेंगे, if I take a string that is connected by a string, then mass here m1 and this exhibit oscillation. अब ये oscillation exhibit करता है. So in that case, so L is not fixed here. L यहाँ पे fixed नहीं है. Because I am not saying that ये जो spring है, this ideal spring with spring constant K or the oscillation produced in the spring are not, I am not neglecting that. If it is mentioned in the problem, this is ideal spring and the oscillations that are produced in the spring are very small. So in that case, there will be no constant due to this spring. But if it is written that L is not fixed, so that means it basically its length is changing. So that means the oscillations that are produced in the spring, so those are, you cannot neglect them. So that will affect the motion of the spring also. Okay. So or you can say that in this case our F will be equal to, so this will be equal to 1 into 2 minus 0 because this will be 2. Why I am saying that there is no degree of freedom? Sorry, what I wrote here. Okay. So that means here, what I said that this L is not fixed. So that means this is free to move because it doesn't cease its motion because this it is L is not fixed here. It is changing. So that means the trajectory or the path of that pendulum is not fixed. So that means it will not cease its motion. You can say that. Okay. So in that case, our beta will be 0. But here, this it is inextensible setting. So that means this length is fixed. So by when the length is fixed, that basically fixes the motion of that pendulum. So इसकी motion कोई particular trajectory बना रही होगी in space. But here the trajectory will not be fixed. So it can be so it can go haphazardly because When this length will change, the oscillation that are produced in this simple pendulum will be different. So that means here there is no constraint due to this supreme, but here is constraint due to this inaccessible supreme. So that is why यहाँ पे मैंने degree of freedom 1 लिया, यहाँ पे degree of freedom 0 लिया. So here the degree of freedom will be 2 in this case, second case, and degree of freedom will be 1. So there are so many examples. If you see some books, so you can see many more examples how to calculate a degree of freedom. Most probably next lecture we are going to discuss the different kinds of constraints, and so these will be the tutorials for your this classical mechanics. And if any problem related to any topic, so you can comment me on my YouTube channel. Thank you very much.